Hey, I'm going to talk today about over design. I'm Rona and I'm a software engineer and a manager. I'm working at Mixtiles and you can find me on Twitter at Lankry Rona. I want to start up with a short story about two groups of people, a group of engineers and a group of teenagers that were giving a mission to cross a river. So both groups sat down and start thinking on how they gonna cross that river. So the group of engineers came up with a solution to build a bridge. They start drawing their bridge and calculating the loads the bridge gonna have and came up with a massive construction plan. And the other group of teenagers um, came up with a solution to build a boat. So they did it. They built a boat and they crossed the river. And after they got to the other side, the group of engineers were still planning and drawing and designing their bridge. So let's talk about over design. When we're building a two-story building, we don't set the foundations for the 50th floor, right? The same should apply for software design. We want to keep things as simple as we can. It will help us along the way. When we're over designing our system, we pay double. First for developing time and second on maintenance. Not to even mention the product changes we're gonna have along the way that will add more time and more complications and more maintenance. In this talk, I will give some tools for identifying and over design and how to avoid it. I'm gonna give some examples and each example will have a guiding question. And in the end, I'm gonna talk a bit about some do's and don'ts. So our first guiding question is, do we really need it? Um, my team were asked to build a system to find data duplications. So we sat down a few engineers and tried to solve this problem and design a system for it. We've First we had to deal with how to find the data duplication, and second we needed to figure out what we're going to do once we found the duplication. Do we want to take the newer data, or do we have another way for figure out which data is more reliable? And we've sat for a few days designing and brainstorming, and then we've presented the design to the rest of the team, and they liked it. We had some comments, but they liked it. And after a few days, we had a meeting with the customer that gives us the data with the duplication. And in this meeting, we figure out that the customer can give us the data without duplication. So, do we really need it? Not always. Guiding question number 2: who is going to use it? In a different company, my team was responsible on designing a new and improved API for one of our services. We had a really long list of requirements. So again, we sat down for designing the new API. The list of requirements, some of the requirements were for the API to be very generic. It should have fit all our service users, to have minimum restrictions on the parameters and on the body. And it caused us to deal with a lot of edge cases. But we did it. We came up with a design and we've implemented it. And after a few months, we've launched the system, the API, and it was great. We were really proud. It was very stable, and after a while, it turns out that we have only 2 users for our new and improved generic API. So who is going to use it? You need to think about it. Our third guiding question is there a simpler way? So imagine you're working in a small startup and you're only 3 developers and you start designing your system for weather forecasting. And you start drawing on the whiteboard. You're going to have one service for crawling and one service for data, for handling all the data and calculating, and another service for presenting the forecast. And it's a really good design. You present it to your CDO, he approves, everything looks great. But in this example, I want to show that even microservices, which is a great architecture, can sometimes be over designing it. You need to ask yourself, is there a simpler way? And in this case, probably 2 services can totally be enough, or even a monolith. Of course, you need to have it separated to models. You do need to keep in mind that maybe one day you will want to split it. But currently, you're only 3 developers. You're a small startup. You don't know what you're really gonna need in the future. So start simple. If in 6 months your startup still exists and you have a growing number of customers, go ahead and split it to microservices. But currently, do the simplest thing you can possibly think of. So, some do's and don'ts. The first do is focus on the problem. Always have the problem you're solving in front of you. It will keep you focused. The second one is keep it simple. When you're designing your system, start with a simple design and keep it as simple as you can. Even after you're launching your system and you're designing a new feature, you always need to have in mind to keep it simple. And my don'ts is don't plan for theoretic needs. Think just on the near future. Let's go back to the river story. How could you avoid over design in this case or in any case? All you need to do is ask yourself 3 simple questions. First question is, do we really need it? Do we really need a bridge to cross a river? Probably not. Who is going to use it? If you have cars crossing the river, sure, go ahead and build a bridge. But if you're going to cross it, you don't need an entire bridge. And is there a simpler way? Of course there is. You can build a boat, you can swim. Just think of a simpler way. So I hope after this talk and you when you next time you're gonna build your system, the 50th floor foundations won't be set unless really needed. And I want to finish up with a quote. Always implement things that when you actually need them, never when you just think you may need them. Thank you.